Extensive material recycling. 3 excavating chains. Big savings in material and logistics. PM1000 URM, the new standard in formation rehabilitation. The PM1000 URM optimizes the recycling of the available material. 3 chains excavate the material in 3 layers. The material from the first 2 chains is recycled. Up to 5 different layers are placed. In addition to the formation protective layer, the recycled ballast and 2 geosynthetics, there is an intermediate protective layer consisting of recycled material. The following shows the sequence of work and flow of material within the machine. The top layer of ballast is removed by the first chain. Coarse soiling is separated from the ballast in the roller sizer. The ballast is pre-cleaned in the finger screen. Metal pieces are picked up by the magnetic separator. The ballast stones are sharpened in the impact mill. Undersized stones are sifted out in the grading screen. The ballast is washed in the high-pressure washing screening unit. The soiled water is treated in the clarification plant. The ballast is ready to be returned to the track. Material in the mixed zone is removed by the second chain. Second magnetic separator. Ballast and undersized stones are separated in the roller sizer with mixer function. The ballast is passed to the recycling process. The undersized stone is used for the new intermediate layer. Using chain number 3, spoil and residue from the recycling process are removed and loaded onto MFS units. The new layer structure. A geosynthetic is laid. The intermediate layer is placed using spiral conveyors and a smoothing device. The formation protective material is supplied using containers and gantry units. A slewing conveyor belt and plate consolidators are used to place the formation protective layer. Ballast chutes with packing device to place the recycled ballast underneath the skeleton track. Y chutes to fill the tamping zones. The track is leveled, lined and tamped. Optional supply of new ballast also using the container system. There is an option to store recycled ballast at start and end of work. All operations are carried out solely in the track under repair. The skeleton track is not removed. The recycling process begins as the top layer of ballast is being excavated. The material is taken to a roller sizer, which pre-cleans the ballast and filters out the oversized stones. Following this, the finger screen frees the ballast of residual fine particles and similar soiling. A magnetic separator removes metal pieces from the ballast. Then the ballast is sharpened in an impact mill. The sharpened ballast, together with the residual fine particles, is sent to the grading screen, where the undersized stones are sifted out. The ballast is taken to the high-pressure washing screening unit. The standardized, recycled, washed ballast is ready to be returned to the track. The soiled water is cleaned in the integrated clarification plant and reused. The second chain enables the innovative enhanced material recycling. This chain picks up the so-called mixed zone, a combination of the remaining ballast bed material and fine material. This excavated material runs over a magnetic separator in the following roller sizer with mixer function. The roller sizer separates the undersized stones from the reusable ballast. Ballast stones larger than 40 millimeters are sent to the ballast recycling process of the first chain. Together with the reclaimed recycling residue, the undersized stones form the basis to produce the intermediate layer. Lasting rehabilitation of the track bed is continued using chain number 3. This chain excavates the remaining material right down to the specified depth. This spoil is taken to the front of the machine, where it is loaded onto standard MFS units. Let's return to the construction gap. The intermediate layer, consisting of recycled material, is laid on an optional geosynthetic by 2 spiral conveyors, followed by consolidators. If required, another geosynthetic can be laid on top, but this is not the case on this site. Here, the new formation protective layer is placed directly on the intermediate layer. The material for this is supplied in containers using gantry units. Two gantry units work in relay action, and the rear unit is able to transport 2 containers at once. When required, the container system is capable of supplying the protective layer material and new ballast simultaneously. The cleaned and washed recycled ballast is placed in 2 phases. Right behind the plate consolidators, the ballast is dropped under the skeleton track using chutes and packing device. Y-chutes are used to fill the tamping zones with ballast. Finally, the track is leveled, lined and tamped. Track geometry and depth of the protective layers are documented using a multi-channel recorder. Apart from this, the PM1000 URM also performs and improves on all known rail-mounted production line methods for mechanized formation rehabilitation. The PM1000 URM offers decisive technical advantages. Identical axle loads in transport and working mode, therefore no restrictions on bridges. Greater track lowering due to new frame construction. Greater thickness of overall layers due to the installation of an intermediate layer and a formation protective layer. Increased tractive force thanks to 16 powered axles. Complete ballast bed renewal with simultaneous continuous installation of rehabilitation layers possible in one pass. The cost and effort for preparation and start of work is reduced because no trench has to be dug under the track, and the time required to thread the chain in and out is reduced. By using the PM1000 URM, great savings can be achieved, not only in spoil disposal costs, but also thanks to the smaller quantity of new material required. For complete ballast bed renewal with placement of a formation protective layer, the subsoil in the ballast bed material must be disposed of 100%. For ballast bed cleaning or ballast bed recycling with placement of a formation protective layer, the subsoil material is evacuated 100%. The ballast bed material to be disposed of is reduced to between 50 and 40%, depending on the type of machine. When using the PM1000 URM, up to 100% of the available ballast bed material can be reused and therefore does not have to be transported from the site. For the material supply, the situation is as follows. For complete ballast bed renewal with placement of a formation protective layer, the intermediate layer and the ballast must be supplied 100%. For ballast bed cleaning or ballast bed recycling with placement of a formation protective layer, the protective layer material must be supplied 100%. For ballast, the supply of new material will be around 50%. When using the PM1000 URM, the intermediate layer can be composed entirely of the available material, depending on the method of work. Then no new material has to be supplied for the formation protective layer. Compared to previous methods, the PM1000 URM has up to 50% fewer logistical breaks, thanks to the enormous savings in supply and evacuation of material. Consequently, peak performances of 120 meters per hour are possible, and that means an increase in the daily output by up to 600 meters. PM1000 URM, the new standard in formation rehabilitation.